Hello, so today I have another live solve for you. This is Boomerang Arrow by Newman. And as you can see, it's quite an interesting looking puzzle. And I will go over the rules now. So first we have normal sudoku rules applying. Additionally, cells that are a chess king's move apart can't contain the same digit. So this is standard anti-king. So that would mean that if I were to say put a 1 in this cell here, then I couldn't, this is a terrible example, put a 1 in here, then I couldn't put a 1 in any of these, like normal Sudoku rules would say I can't put a 1 in these two cells. But if you look at all the cells that surround it, that's where king could move in chess. And so these 4 cells also can't be a 1. So we're really looking at the diagonals as cannot repeat. So in this particular case, this cell already couldn't be a 1 because it's the same box, but none of these cells can be a 1. So you can see that F puzzles will show that as red. So it does enforce that rule for you. Additionally, digits along an arrow. So this is an arrow. They have to sum to the pill shape that's connected to the arrow. So if I were to add up all of these cells together, they would equal whatever number is written here. And we read it left to right or top to bottom as a 2-digit number. So if this were 41, for example, then these cells here would have to add to 41. Okay. And additionally, we have black dots. So we have standard Kropki dots. So the black dots means that the 2 digits must have a ratio of 1 to 2. So for example, I could put 1, 2 here, or I could put 2, 4, or maybe 4, 8, or say 3, 6. And so as long as you take the larger one, divide it by the smaller one, and you get 2, that is the ratio of 1 to 2. And additionally, cells separated by a white dot have to be consecutive. So if I put a 2 here, I have to put a 3 here. I can't put a 4, but I could put a 1. So another way to put that is if you take the larger one and you subtract the smaller one, you get 1. And not all the dots are given, so I could put, say, 1, 2 here, and that's not a problem at all. So those are the rules. I know it's combining a few different constraints. Don't forget about the king's constraint, which I'm partially telling to myself as well. So again, we have anti-king, we have standard arrows, where we have the 2-digit pill for the arrows, which always read left to right or top to bottom for the 2-digit number. And we have the Kropki dots. So those are the rules. Go ahead and check the description below for a link to try this yourself. I'm told it's not too bad, whatever that means. So we'll see how it goes. And I will get started. So I think the thing that's very interesting about the construction of this puzzle is we have a bunch of these arrows that use up 6 of the cells in a box. So all of these arrows are using 6 cells in the box. I think that's true of most of these boxes. This arrow is obviously very special. That's very large. But these other ones, we're using 6 in the box and then 1 in an adjacent box. Just like here, 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 here. And then, of course, we have the 2 digits within it. So I don't know if I should start with this super big one. That could be a good start. But also something to think about is how these two are kind of related. And these two are related. And these two are related in some way that's a bit difficult to think about. But we do know that within a box, all of the cells, if you added all the digits 1 through 9 would appear in the box. Those add to 45. So these pills here can't exceed 45, and they have to be significantly less than 45. Well, could they exceed 45, I guess is a question. I don't see how. So if we were, say, 46 in one of these pills, this would be a bad example. Maybe this one here. Like if we were 46, just to try this out, then we know that these 7 cells have to add to 45 minus 10, because that's what's left for the box. So these would add to 35. We could make this one as low as possible. We could make this one a 1 to get us to add to 34. And that's the highest we could make of these 6, is 34. But then this one would have to make up the difference between 34 and 46, which is 12. And there's no way we could put 12 in one cell. So I don't think it's possible to be higher than 45. In fact, we could figure out what the lowest possible sum is, or sorry, the highest possible sum is in here. So these could add up 4 through 9, which is 45 minus 6. So I think these can add to 39. Is that right? 4, 5, 6, 7, 8, 9. So that's 45, and we're missing 1, 2, 3. 1, 2, 3 adds to 6. So these could add to 39 if they were 4, 5, 6, 7, 8, 9. If they added to 39, though, whatever this adds in, by definition, would put a 4 in the tens place. And so then we couldn't use 4 here. We'd have to use 3 here, which actually makes these add to 38. Am I about to disprove what I just thought I proved about 46? I don't know. And then this could be a 9. Am I thinking about this wrong? 30. So 8. Let's see. Just double checking my arithmetic here. 1 through 9 adds to 45. We're missing 1, 2, and 4, which add to 7. 45 minus 7 is 38. So these add to 38, plus 9, that adds to 47. So maybe 46 isn't possible, but 47 is. Oh no, but then if that adds to 47, I can't have a 7 in here. That's right. So that's the issue that we're running into. And so now I can't have 7 in here. Yeah, so there's kind of a weird thing going there. I think that probably means 43 is possible. We obviously can't do 44 because that repeats the 4. So if we had 43, these could add 5, 6, 7, 8, 9, and then we'd have a 2 in addition to that. And so that adds to 37, if I'm remembering my math right. Yeah, because we're missing 1, 3, and 4, which add to 8. And 45 minus 8 is 37. So 43 minus 37 is going to be 6. So we could put a 6 here. And then, so I think 43 is actually our highest possible value. Maybe 45? Sorry for doing all this, but I want to get a handle on what we're allowed to do here. So we can't have 4 and 5, so we'd have to have 2 and 3 here. So this adds to, we're missing 1, 4, and 5, so we're missing 10. So this adds to 35. So we'd have to put a 10 here, right? So I think 43 is our max in any of these pills that have this 6 plus 1, have the 7 long arrow. I'm sure that's kind of a weird way to get at that, but what's the lowest we could go? Like, can we have 19 here? That seems unlikely. This could be 2, 3, 4, 5, 6, 7 at its lowest, and this can be a 1. So that's 1 through 7 added up, which is 45 minus 17, which is 35, 28. So yeah, we can't have a ones digit here. So all of these, I guess what I could say is all of these high digits, which I need to make sure I click the correct digit that is the high digit. So the topmost one or the leftmost one, not this one. It's going to be 2, 3, or 4. So I think that's a decent place to start. What about this one here? So we know this is 45. So at minimum, let's say that we're just 1, 2, 3, 4, 5, 6. That's going to add to, let's just add it, 6, 10, 15, 21. And then this at lowest is a 1. So this would be 46 plus 21. Let's just say that 22 here. So this is 22 plus 45 is 66. So at minimum, this is a 6. And I'm pretty sure we could get all the way to 9. But we can't actually have a 9 or a 7 on a black dot. So what could these be max? Say we want to be 80 something. That means we can be 9, 7, 6, 5, 4, 3 at our highest. And this could be 9. So, and this is obviously always 45. So this would be 45 minus 3 is 42, minus 8 is 34. So 34 plus 9 is 43, sorry. Plus 45 is well over 80 something. So yeah, so this is 6 or 8, which means this is 3 or 4. So we're either 84 or 63. That's pretty limited for this sum. I wonder if I need to look at that at the moment. Let's do some of these easy ones here. So a 2 would have to be with a 4, a 3 would have to be with a 6, and a 4 could be with a 2 or an 8. This has to be consecutive, so this is 1, 2, 3, 4, or 5. This has no restriction. This is the same as the other one, 2, 4, 6, 8. And these are also 1, 2, 3, 4, 5. Okay. So what's the next step? I do, maybe this is kind of a, like what are our actual options? Let's start with 63. So we can subtract 45 from that. So 63 minus 40 is 23. Minus another 5 is 18. And this would have to be 1, 2, 4, 5, 6, 7. I think that already blows the bank. 7, 14. Yeah, and then another 11 is 20 something. So I don't think 63 is possible. Wait, why did I include 6 here? I can't even include 6. Yeah, that's just way too much. So I'm not 63. I'm 84. This one's 84. That means this can't be 8 or 4. So 2 would have to be with 4, and 6 would have to be with 3. 2 could be with 1, but I don't think I think we can't have a 1 in the high digit here. So we proved that already. Can I limit this further? Is 42 possible? I think 42 is just possible, but it requires a lot of high numbers. What else can we do here? Well, with 84, we can calculate what these have to add up to. I don't know if that's going to be helpful, but we'll see. Let me take a drink first. Maybe I should have set up my calculator here. Just to make things easier, I will open up a calculator. Just give me 1 second. Okay, so I have set up a calculator now. You can see it right underneath the, should be pointing straight up actually. So yeah, right there. That's the calculator right under the title. So that's just a view of my little calculator screen there. So hopefully that'll help. So 84 minus 45 is 39. So in these 7 cells, I need 39. And let's just find out what the maximum we can be here is. So we can have 9, 7, 6, 5, 3, and 2. That's 6 digits, I believe. Yeah. And so those add to 2 plus 3 plus 5 plus 6 plus 7 plus 9. Those add to 32. So at most, this adds to 32, which means at least this needs to be 7 because we needed 39. So this is 7, 8, or 9. And so we get, what does that mean exactly? We can exchange the 1, but only for one of the smaller digits. So I think we can have a 1 if we get rid of the 3. So if I want to add to 30, 1 plus 2 plus 5 plus 6 plus 7 plus 9 is 30. So yeah, I can have a 1 in here for the 2 or the 3, but I must have 5, 6, 7, 9 here. So that means this is 1, 2, or 3. Pretty sure that's good logic. This can't be a 4, and if it were a 5, then I wouldn't be able to add up to enough, because I'd be 1 plus 2 plus 3 plus 6 plus 7 plus 9 is 28, and I'd have to get to 39, so I'd have to put 11 in this cell. So yeah. So this is 7, 8, or 9. This is 1, 2, or 3. We do have King's Move. I don't want to forget about that. So that only applies between these boxes. So I'm not entirely sure where it would apply. I don't think it would apply with anything I've done so far. I'm guessing it won't apply until I get a bit more into the puzzle, and by that time I'll have forgotten about the constraint, so good, good. Look forward to that. What else can we do? This can be practically anything. This 4C is up here, so this doesn't add to 40 something. So if it's not a 4, this isn't a 5, because these have to be consecutive. 3 would go with 2, 2 would go with 3, 1 would go with 2. So can we be 21? So if this were 21, these at minimum would be 3, 4, 5, 6, 7, 8, which way blows the bank. So I can't do 21. So this is either 23 or 32. So these aren't 2, 3. Is 23 possible? It may not be, because we'd be 1 and then 4, 5, 6, 7, 8, it looks like. Plus another one here, can't forget that. So 1 plus 4 plus 5 plus 6 plus 7 plus 8 is 31. Yeah, okay. So not only do we have to be 32, but these minimums add to 31. So they have to be the minimums. And then I have a 1 here. Let's just double check that sum. It was 1 plus 4 plus 5 plus 6 plus 7 plus 8 is 31. Plus 1 is 32, which means this has to be 9. So we know what this adds to now. Let's do that in a second. I'm going to finish cleaning this up. These can't be 1. Does this one means this can't be 1. Okay, I think that's it. Okay, so now let's go back to here. So we know 84 minus 45 was 39. We have a 9 already, that's 30. So these have to add to 30. 30 and 6 cells. If I was better at killer Sudoku, I would probably know what the choices were there. But I do know, let's see, can we not include a 1? So if we don't include a 1, we'd be 2 plus 3 plus 5 plus 6 plus 7. All right, it would be all the digits except 1, 8, and 4, right? Okay, so we know we're not including 8 and 4. So I have to have a 3 here. I think that's the easiest math to do. All of these add to 45. I need these to add to 30. We have an 8 and 4 already, so we subtract 12 to get 33. And then this one we have to be able to subtract from 33 to get 30 here. So this is the 3. And then these can't be 3. That's good. These can't be 9. I didn't remove that. This is starting to get a bit more limited. Okay, so what did we learn here? Does this 3 see anywhere, or this 8? No, we did the 8 already. Might as well fill this as 4, 5, 6, 7, or 8. All of which are possible. Well, it's not 4. We at least know that. So what's missing here? We need a 1. So one of these is a 1, interestingly. Wait, where's my 1 in here? I think I just didn't add it. So never mind about that. All of these can be a 1. Okay. So this can be, if this were a 1, this would have to be a 2. Otherwise, we can't be a 4. So 5 would be a 6. 6 would be a 5 or a 7. And a 7 would be a 6 or an 8. But we can be any of those? We can't be a 2. Okay, so if this can't be a 2, this can't be a 1. So we're back to what we had. But this can be a 1. So that's important. Okay, so is there anything? There's nothing with King's Move yet. These can't be 9. Okay, so this doesn't start with 2. Do I need to just move around the board this way? Because we kind of know, with this being a 1, we may know more about what this sum can be, especially since these have to be consecutive. So we're either 32, 34, 43, or 45. And do I just go through each one? I don't think 45 is going to be possible, is it? I think we already proved you can't do 45, because these, if this is 45, these are going to be all the other numbers added together. So we'd be 45 minus 10, because these would add to, if this was 45, these would add to 10. So this would be 35, and we'd need a 10 here to make up for that. So this isn't 45. So this isn't 5. Get another drink of water here. Sorry, I was just thinking about regular Sudoku for a second. What 3 is one of these? Okay, let's get back to that. So it's not 45. Can it be 43 then? Because that's the only other option for 40. So 45 minus, so 4 plus 3 is 7, plus 1 is 8. So we'd want, these would have to add to 37, and we'd have to get to 43. Oops. So that would make this a 6, which does seem possible. So if this were 43, 3, then this is a 6. What if this were 34? So that would still add to 37. Wait, is that right? Yeah, if this were 3, 4, then the rest would have to add to 45 minus 8 is 37. So there's no way 37 plus whatever this is adds to 34. So this isn't 34. 32 probably has a similar issue because we would add to 6. 45 minus 6 is 39, so that's even worse. So this has to be 43 then. And so then this has to be 6, and these are whatever's left over from that. So let's just double check that. We would be 2 plus 5 plus 6 plus 7 plus 8 plus 9 plus 6 is 43. Yes, that does work. So now this 6 here, we can do some eliminations. This isn't 6, so this isn't 3. I guess it could never have been 3 anyway. This 4 sees here. This 3 means there's a 3 in one of these 3. Just from these 2 3s looking over into here. Do I get anything else here? Still nothing with the king's move. Oh, this one here. This can't be 1. Not super helpful, but we'll take anything. It does feel like I just go around the board here. So these 2 can't be, so these can't be 6. 6 is one of these 3. I don't know if that's helpful to mark or not. In order for this to be 8, this would have to be 4, and I don't think that's possible. We can't do 48, right? Because these would add to 45 minus 4 minus 8 minus 6. So these would add to 27. How are we going to get to 48 from 27 with one more cell? There's no way. So this actually isn't an 8, which means this is either 24 or 42. And I'm a bit skeptical about 24. Let's try that first. Well, either way, actually, we would add to 45 minus 12, because these 3 add to 12 no matter what. Okay, that means these aren't 4. Sorry, let me just do that real quick. I'll come back to that. So 33, these add to 33. So this has to be 42. And then 42 minus 33 is 9. So this is just barely makes the cut and is a 9. Which means 9 is one of these 3. I was also seeing that 9 has to be one of these 2, because we have 5, 7, 8, 9 left in this row to fill. And so one of these 2 is a 9, because these can't be 9, because there's a 9 in the box already. So that means, oh yeah, this could never have been 9. So 9's one of these 2. It feels like progress, and at the same time not so much. Okay, we can actually skip down a little bit here. This then has to be 36. So 45 minus 9 is 36. So these 2 cells are the same value. Don't know if you followed that, but the whole box adds to 45. If we subtract 9 from 45, that means these 7 cells add to 36, which is the sum we need. So when we remove this value from the sum, we have to use this value to add to the sum. So these 2 are the same. I'll just mark that in blue to remember that these 2 are the same value. So we could actually probably reduce the possibilities by what they all see. So we can be a 1, a 2, can't be 3, 4, we can be 5, can't be 6, or 8, so we can be 7 though. That's less restricted than I thought it would be. But we'll keep that in mind. 1, 2, 5, 7. Okay. Maybe we can do this one now. It can't be 2. There's no dot or anything here, so that makes it a lot less restricted. How about this one? This can't be 3. In fact, 3 must be one of these two. Just from these two 3s looking in and this 3 looking down. This can't be 3, 6 because there's a 6 in the column. So it's 2, 4, or 8, or 1. This also sees a 3, so this is 1, 2, 4, or 8. Four is one of these two. Okay, if 4 is one of these two, then neither of these can be 4 because of the king's move constraint. Because either 4 is going to be here, in which case these two can't be, or 4 is here, in which case these two can be. Another way to put it is if I put a 4 in either of these two, it removes the possibility of putting a 4 in this box. So this isn't 4. I don't think that restricts what this can be. Well, no, that means this can't be 8, right? Because 8 requires a 4 here, so we can't do that anymore. So it's either a 1-2 pair, or it's a 4-8 pair this way. It's either 1-2 in some direction, or it's 4-8 this way. That's what I meant to say. Not super helpful, but we're narrowing things down. There's probably something obvious I'm missing about this. Maybe I just look at this sum here. We know this is 9. So 45 minus 9 is 36. So these add to, at most, 35, which means this can't start with a 4, right? Well, no, so I think without a 9, we're going to have a tough time making this add to 40-something. Let's try 41. So if this were 41, then these 6 cells would add to 45 minus 14, which is 31. And so in order to get to 41, we'd have to put a 10 here. And I think it gets worse with 42, because that increases what we're subtracting from 45 here. So this starts with 3. So this isn't 3. In fact, 3 then has to be here. These two 3s look up. This 3 looks over. And that's a 6. So, oh, we also have this 3. So, are we close to being done with 3s? Well, this isn't 3. Not as close as I'd like. All right. So we've got 3s in these cells left, I think. Okay, well, let's keep going. So what can this add to? 30 something. So what do these add to? 45 minus 12 is 33. So how do I want to think about this? I can't add to 31 because that would mean this adds to 32. Right, these add to 33 minus whatever is here. So if I make this a 1, then these add to 32. And then that would have to, this would have to be -1. So It's not 31. 32 would mean these add to 31, and this would be 1, so that's possible. So this could be 32. Maybe a way to think about that is, how would I think about that? Let's do a few more examples. 34 would mean these add to 29. Let's just double check that. So 45 minus 3 minus 4 is 38, or minus 9 is 29. And so if I want to add to 34, let's just mark that, 34, then this would have to be a 5. So I think 2 here isn't possible, which means 2 here is not possible. Does that mean that there's some weird relationship that I'm not understanding? I could probably try to express an equation here. It's a bit strange, but let me pull up a notepad, because I really do want to try to understand this. So here's a notepad. Let me just make it a little bit smaller here, and I won't hide the important bits of the puzzle. So we know that these 6 cells add to, let's just mark these a color so I can call that something. So purple is equal to 45 minus 12 minus, let's give this another color. Let's call that light green. So green here. So that is equal to 45 minus 12 is 33. Minus green. So purple is 33 minus green. And then we've got 33, or we got purple plus blue is equal to 30 plus green. And the way we think about that is if we take the purple cells, which are part of this arrow, and we add the blue cell, that's the arrow total, which is 30 something. So it's going to be 30 plus whatever our green single digit is. So we can replace this green here. Well, we want to know what blue is in relation to green, I think. So let's put 33 minus green in replacement of purple. Plus blue is 30 minus green. So I can add, is this going to give me blue equals 2? Am I? No, I think. What am I doing wrong here? So if the greens cancel out because I have minus green on both sides. So that's 33 plus blue equals 30. That would make blue equal to -3. So clearly I am not thinking about this correctly. Let's try this again. So the purple cells, so we know that this whole box adds to 45. So 45 minus 9 minus 3 is 33. So if I take 33 and I subtract green, that gives me what the purple cells add to. That's P. P is 33 minus green. We also know that purple plus blue is equal to 30 plus green. So if purple is 33 minus green, then 33 minus green plus blue, I transcribed it wrong. That's 30 plus green. So greens do not cancel, so that makes a lot more sense. So I can subtract 30 from both sides. and add green to both sides to get 3 plus blue equals 2 green. So blue is equal to 2 green minus 3. So so if green is, maybe I should do it the other way and say that 3 plus blue over 2 is equal to green. So I think that's the equation we want. Let's double check that. With 2, that makes, sorry, if blue were 1, that makes green 2, and we did do that. If blue were 5, 8 over 2 is 4. Okay, and so then if blue were 7, then that's 10 over 2, so that puts a 5 here. So all that I just wanted to understand the relationship. I'm sorry for taking so long on that, but I think that was interesting. And so now we have the equation. So if we narrow down the blue any further, that'll allow us to figure out the green. It was probably overthinking it though. Okay, 6 is C into this box. So 6 is one of these two. Interestingly, if we look at where 2 can go in this box, none of these can be 2, and this 2 sees down into here. So 2 is in one of these 3, which means actually these can't be 2. And so these can't be 1. This is 4, 8. That makes this 35. And with our equation, which I will go back to, that means 5 plus, we can use this equation here. 10 minus 3 is 7, so that makes this a 7. So both of these are 7. So I can get rid of all this coloring now. So that was actually useful. Okay. What else can we do? Well, we know that 2 is going to be one of these two. There's 4 digits left here. We need a 1, 2, 5, and 9, looks like. This can't be 2. This can't be 5. This can't be 1. Okay, nothing too special going on there. These have 4 left as well. So we need 1, 2, 7, and 9. This can't be 2 or 9. These can be any of them. All right, is there anything? So I think this sums next. I think this shouldn't be too hard to figure out because we know this value and this value. So do we do another equation or do we just fiddle with it? These have to be consecutive as well. I don't think 21 is going to happen. We can't do 23 anymore. 21 would mean we have 45 minus 10. So this would be, yeah, this would add to 35. So there's no way. So this isn't 21. Oops. So that's not 21. Can we be, I don't think we can be 45. We can't be 43. So this might be a 3. Let's find out. So if this is a 4, this has to be 45 because of the consecutive rule. So if this is 45, then these add to 29. And there's no way we're getting 29 plus 3 to equal 45 anytime soon. So we fill a 3 in there. And so then this is 32 or 34. And I think we should be able to just figure that out. So 45 minus 7 minus 3, that's obviously 35. That seems bad. Okay, I don't think it's bad. These two are equal. So that doesn't mean it. It's the 7 here. So the difference of 4. Sorry, I'm blanking on how to think about this. I'm sure it's easy. So if I wanted to add to 32, that doesn't seem possible. Let me think about this. So if this were 32, let's just do it that way. If this were 32, then these would add to 45 minus 12. These would add to 33, so that's not possible. So I'm hoping 34 is possible. Should be. So 45 minus 14 is 31. So these add, yes, these add to 31, and then this is a 3. So that actually works. That's great. So I think we have all of our arrow sums. Yeah, we have all of our pills filled. We have all of our arrow ends filled as well. So the only thing left, and so that means that our sums are guaranteed to work. So we don't have to worry about our sums at all anymore. So all we have to worry about is our Kropki dots and the king's move constraint. And so hopefully we are on the home stretch, actually. This was a really interesting puzzle. So what is the next step, though? 7 has to be in one of these two, because 7 can't, oh sorry, actually 7 is limited to here, is that right? 7 can't be in these two, can't be in these two, and then the king's move rules it out from here. So this is 7, this is 6, this can't be 6. That means this forces a 7 here. So these two aren't 7. I don't know what I just pressed, but it didn't do anything. 1, 2, 9 triple means this is a 5. I said 5. Another 1, 2, 9 triple. So this is a pair. This is, we have 1, 2, 3, we need 4 and 8. That makes sense. This is also a pair, so it's going to be 1, 2 pair. So I think that means, oh yeah, this can't be 3. We already have a 3 placed. So don't get confused by my old pencil marks. 1, 2, 3, we need a 5 and a 5 and 8, looks like. None of that looks resolved. Are any of these pairs resolved? Yes, this one here. This is 8, 4. That 4 sees here. This is 8, 4. That was king's move. I haven't forgotten about it yet, so that's pretty awesome. That means this is a 1, 2 pair. This is going to be a pair, and we need a 9, right? Yeah, so this is 9. And this is 1. We are definitely doing well. That's great. What else do I need here? This can't be 4. Wonder how long that's been sitting there. So that means a 4 is here. One, 5. This can't be 1. Is 5, 6, 7, 8 the remaining? Oh, these can't be 7. What am I missing then? 1, 2. Yeah, where does 2 go? Okay, so this is there's a 2 in one of these two. It's not a pair because this could also be 6. In fact, I don't think I need. Yeah, I'll just try to keep track. Sorry, I'm getting a little slow here. This 8 sees here. So this can't be 7 anymore because it doesn't have a buddy. It doesn't have 6 or 8. Can't be 5 either, right? So this has to be 6. None of those are 6. So this is 1, 5, 7, or 8. So that means one of these two is an 8. Six is in one of these two, just based on this box here. So this can't be 6. That sticks a 6 in here somewhere. I feel like I'm missing something important, just regular Sudoku wise. What is it though? 4? Yeah, so 4 in this box, where does it go? Can't go here, can't go here. This 4 sees in. Right, so the 4 sees these 3. This 4 sees all 3 of those. This 4 sees these 3. 4 can't be here because of the dot. And this 4 also sees down into here. So the 4 goes here. I think that's the last 4. Okay. What about... Should I just go through the numbers? Yeah, 1 in this box has to go here, just based on my pencil marks. Yeah, we have a 1-2 pair looking up here, and this one looks over there. So there's a 1 here. This 1-2 pair means these can't be 1, 2. And these can't be 1, so the 1 goes here. Anything else with 1s? 1 is in one of these two, as well as one of these two. I think that's all I get out of 1s right now. Twos. Two is in one of these two. Ah, this white dot here, this is an 8, 5. Sorry for missing that for so long. These aren't 8. Does that mean this is 6, 7, 8 left? Yes, it is. This 6 is here. Ah, so this is a naked single 8. So these are a 6, 7 pair. Anything I can do with that? No. Where do 9s go? 9's in one of these two. I think that means this is a triple. Is this a naked single? Can't be 1, 2. Can't be 3, 4, 5. Can be 6. Can be 6 or 7, 8, 9. So, but I think if it were 7, it would screw up what I've corner marked here. Okay. This is easier to see. This is a 5, 7, 8 triple, so this has to be 6. So this is a 3, 9 pair. These aren't 9. So 9's one of these two. I don't think that's enough to do anything with 9's in this box. The final Sudoku here has not been easy for some reason. Probably related to King's move. This can't be 5. . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . . So these are 1, 2, 7, 8. It's not a 1. It's not a 7 or an 8. So I got a 1, 2 pair here. So this is a 7, 8 pair. Anything see that? No. I feel like I'm just not scanning something important here. 7 sees up here. That means one of these two is a 7. This 8 sees up here. I mean, this is the only place for an 8. Yes, it does. So this is an 8. These aren't 8. Sorry for taking so long to clean this up. This can't be 7. Threes look into this center box. That means 3 is one of these two. Are there any weak rows or columns that I haven't? How about this one? We need 1, 2, 5, 8, 9. This is not 1. I think that's it. Is there a rule I'm forgetting about? Well, we know 9's not here, because 9's limited to one of these two. Do I just fill the rest? Might as well. For the row, we need 2, 5, 6, 7, 9. 7's in the box. That means one of these two is a 7, is that right? Yeah, so for this row, where does 7 go? Only goes in one of these two. So these can't be 7. They couldn't have been anyway. All right. Only thing left is to fill is this box here. Okay, this column, do I just fill? Can't have a 3, 4, or 7 here. 7 already eliminated. Or an 8. 3 or 1. And then here we can't have 7s. This can't be a 3 from King's Move. These can't be 6 for the row. We have a 1, 2 pair in the row. So these can't be 1 or 2. So in this row, where does 6 go? It doesn't go here, it doesn't go here. I guess it's any of these 3. Is this true? Okay, if this were 1, that forces a 1 here because of King's Move, which forces a 1 here, and then that clashes. So I think a better way to put that is in this row, 1 can only be here or here. Either way, it eliminates this from being 1. It's not much, but it's honest work. Anything else like that? Yeah, so I limited 2 to one of these two. That's what I was missing, I think. Yeah, in this row, 2 can only be here or here. By King's Move, that eliminates this 2, because either one's going to eliminate the 2 here. So this is the 1, and that should finish off my 1, 2s. Some of them, at least. 2 is now down here somewhere. All 3 of them see this too. Is that not enough? What did I fill? Fill 1 2s, 1 2. This 6 here sees this one. So that finishes off this box. That should be very helpful. That's a 5 9 pair. So this isn't 5. So that's a 2 6 pair. So this is the 7. This is not 7. 7 sees down here. So based on our corner marks, that's a 7. This is a 9 for the column. This is a 2 5 pair, which is not resolved. Five would put a 7 here, but I don't see a problem with that. I keep getting these little spots that don't quite carry me. Oh, this 3 sees here. I don't know why I ever marked that 3. In fact, it wasn't even a 3 here. Does that limit 3 to just there in the box? It does. 3 is in the middle of the box, so that's 9 3. These aren't 9. That leaves 9 to be down here somewhere. So by the same logic, this one can't be 9. In fact, there's a 9 in the row now, so that can't be 9 either. This 9 also sees here. So 9 can be any of these 3. Not super helpful. Just looking for more king's moves. It's really at the edge of boxes that it matters. This 9 sees here. Almost done. What is the last? This 5 here. Okay. So this is a 6. Did that? Oh yeah, here. 2 6. This 2 does see here. 6 sees down here, so this is a 6. Keep thinking there's just one more to get, and it just doesn't finish the puzzle. It is holding on tight. It's got its hand on the cliff face and it's dangling. What's that mean when we solve a puzzle? I don't want to think about that. Ooh. More king's move? Maybe? Ah, okay. So 9s are limited here and here in these boxes, which means in box 8, 9 is in this column. Can't be here, so it's here. Which means it's not in these 2. Not here either. This is a 1 2 pair, so this is a 9. I think that just leaves these 2 for 9s. Still not done. Do let me know if you also struggled getting this finished, because this is incredible how much this is holding on. And I feel like I'm just not doing a proper job scanning, but maybe it's just hard to spot everything. So let me know how you did on that. Trying to finish. I mean, I've got a uniqueness argument here where this must be 2, otherwise we... Unless there's a... Well, there could be a king's move that also resolves a 5-9 deadly pattern. That's the issue. Could any of these... Like, for example, if this were 5... Well, no, this couldn't... 5s are... No, 5s could be anywhere here, yeah. If this were 5, for example, that would resolve a 5-9 deadly pattern. So we can't just put a 2 here with the uniqueness. Not that I would anyway, but even if you wanted to, I don't think it would be guaranteed to work. You'd get lucky if that worked. 2 is one of these 2. 7 is one of these 2. And one of these 2. Like, I'm just not... I'm not seeing it. 2, 5, 8. Where is the disambiguation for all this? Would a 5 here be problematic? It gets rid of all 3 of those 5s. It forces a 5 here. So 5 here, 5 here, 5 here. 2, 1, 9. Is that a problem? Five, 2, 1. What am I seeing with this? Is there some sort of triple or... I'm seeing a hidden single 8 is what I'm seeing in this column. This has to be 8. All right, there we go. 2, 5 pair means this is 1, 2, 1. Oh, don't stop there. 8's one of these 2. This can still disambiguate a deadly pattern. 7s, no. Every time I think I go, okay, that was it. That was the spot, and then it just keeps on going. Amazing. Probably just my own failure to see things, but I wonder if it has something to do with this. Like this being a 5, forcing a 7 here. So we'd have 5, 7, 2, forces a 5 here. Yeah, I think that's a problem. Maybe there's a better way to see that, but a 5 here puts a 7 here and a 2 here, forcing this to be 5. Yeah, there is an easier way to see that. 2 is limited to these 2, which means this can't be 2, because it removes 2 from this box. So this has to be 5. That means this is 8, 7, 2. Ah, it is a deadly pattern 5, 9, disambiguated by a 5 here. Take that, people who want to use uniqueness. All right, this is 5, 2. This 5 sees here. This is 7, 8, and 5. And finally, we did it. Let me just move my calculator out of the way. Yep. We have a green timer. So that is how you solve Boomerang Arrow by Philip Newman. I'm sorry for the long ending there. Do let me know if you struggled like me or if it was a piece of cake like it probably should have been. So yeah, that is the puzzle. Please remember to subscribe if you want to see more puzzles from me. Sorry for taking so long between this puzzle and the last one. I do have some other obligations that got in the way of finding time to film a video, but I will try to keep up and keep making videos for you guys. I do have a backlog of puzzles to solve, so hope you enjoyed this. Hope you enjoyed the puzzle, and until next time, have a good one.